Myself, Dr. K. Viswanath Allamraju, Institute of Aeronautical Engineering, Hyderabad, India. Today we are going to study the types of CAMs and types of followers. Before class, we have studied Introduction to CAMs. In Introduction to CAMs lecture, also we have studied little bit portion of types of CAMs. Let us begin. What are the types of CAMs? In introduction, that CAMs are classified based on three categories. Number one, according to the shape and the follower movement and the manner of constraint of the follower. According to the shape, the first type is called wedge or flat cams. So figure A, B and C represents the different wedges. In the case of figure A, the wedge is the driving member and the follower is a driven member. The wedge is under motion and the follower follows, and the G, there are three components are here. G is the guide. The guide remains fixed. In the case of figure C, the wedge remains fixed and the follower is the driving member and the G, guided member, is the guided. G is the output, the driven member. So these are the three varieties of wedge cams. So this is figure 7.2 also represents wedge cam. But here in this case, a flat plate is covered with a groove. So it is the positive drive. Why? Because the roller is completely follows the groove of the flat plate. So when it is, the wedge is moving, horizontal translatory motion, the follower moves, vertical translatory motion. In this case, the wedge is the driving member and follower is the driven member and the G, guide, remains fixed. Now, second type of shape based on under the shape category, radial or disc cams. So we have studied this is a radial cam. The radial cam, and it is a disc, circular disc cam. So in this, it comes under the category of open closed pair category. Here it is closed pair and it is open pair. And here it is spiral cams. The spiral cams, if you see, the spiral cam, the motion of the follower is dependent on the shape of the spiral groove. Generally, this type of cams are very limited in use. It can be used for reverse purpose also. When the cam is rotating in clockwise direction, the follower moves in anti-clockwise. And the follower touch with the gate. Here the follower remains, it doesn't move. It moves up and down, vertical translatory motion. Okay. As in the case of cylindrical cams, if you see in the case of cylindrical cams, what is happening? In the case of cylindrical cams, we'll study here, this is a spiral cam. In the spiral groove consists of a teeth. And it is a gear, it is a bevel gear. This teeth, the follower at the one end portion is connected to gear, that those gear teeth are in contact with the spiral teeth. When the gear teeth of the follower always in contact, in mesh with the spiral groove's teeth. So when the cam is moving, when the cam is oscillating, when the cam is rotating under rotary motion, this follower always in touch through the gear, so it moves up and down. The fourth type of shape of the cams is cylindrical cams. In the case of cylindrical cams, cam is the shape of a cylinder. On the surface of the cylinder, there is a groove will be there, and the groove is in touch with the follower at one end, exactly groove. When it is cylindrical, the cam is rotating. What will happen? This groove, based on the direction, yes, it will oscillate in this motion, oscillatory. So here 7.55b, we can see here the springly loaded roller follower. This roller follower in touch with the surface of the cam. Again, that's why it is called cylindrical cam. The geometry. Cylindrical cam means the shape, the geometry of the cam is in cylindrical. By using the cylindrical shape, we are going to give the rotary motion or reciprocatory motion of the cam is converted into the rotary motion or translatory motion of the cam. In the case of in this figure, the rotary motion of the cam is converted into the reciprocating motion of the follower. Here, the rotary motion of the cam is converted into oscillatory motion. Next, these cylindrical cams also known as barrel or drum cams. Next category, next type is called conjugate cams. In the case of conjugate cam, what is happening? You can see it. There are two types of discs. The front disc is the dark line, and the back side of the disc, that is the dotted line here mentioned. So there are two rollers and two discs. What will happen? The two rollers are in contact continuously when the disc, the mechanism is such a way that the design of the cam is such a way that the motion, the torque can be transferred continuously to the follower. So where such type of conjugate cams, this type of conjugate cams are used, where the low noise, better control of the follower, and high speed and high dynamic loads. So there, this type of conjugate cams are used. Next, globoidal cams. These are globoidal. In globoidal cams, again two types. One is convex and the other one is concave. Again here completely the motion, the driving member is convex surface of the cam, driven member is the follower, so it is completely oscillatory motion. Here it is spherical cams. Is the sphere, on the surface of the sphere there will be a groove. It follows. So that is the first category, that based on the shape, the types of cams are, there are total 7 number. Next, based on the follower movement, just a glance in quick reading, we'll understand the types of cams. Here it is triple R, that is raise, return, raise. And raise, return and raise. The follower rise means it goes up and again it goes down. Goes up and goes down. Only going up and down. There is no dwelling. Coming to figure C. In the case of figure C, dwell, rise, dwell, return. Again dwell. Okay, dr, dr, d. So dr, dr, d is the figure C. But that is the third category. Now it is, if you see D, rise, dwell, rise, return, dwell. dr, rd. So that is second category. Now third category is that dr, drd. That is based on the movement of the follower. Now third category, that is the third category, that is called based on the manner of constraint of the follower. The manner of the constraint, if it is attached to spring, that is called preloaded spring cam, and it is a groove. When the cam is designed with a groove, then it is called a positive drive cam. When the cam is rotating but the follower is always in touch with the cam by the gravity force, then it is called gravity cam. Now what is a preloaded spring? The preloaded spring is a compression spring. Is used for the purpose of keeping the contact between the cam and the follower. Next, positive drive cam. Here the constant touch between the cam and follower is maintained. For what? By a roller follower operating in a groove of the cam. Operating in the groove of the cam, as you have seen before. These are all comes under positive drive cams, 7.2, 7.3. So these are the groove of the cams. You see 7.2. These are the groove of the cams followed. Okay, all these comes under the category of positive drive cam. So what is the advantage of positive drive cam? Why we call it as a positive? Because the follower cannot go out of the groove. Okay, under all normal working conditions, it will not go out. It is exactly follows the groove. There is no more going away from the track of the groove. So a constraint, that's why it is called a constraint of the follower, because when the follower is completely constrained of predetermination of the groove, predetermined path of the groove of the cam. That's why it is a constraint or a positive. Is also obtained by the, and also there is another cam. The positive drive cam is called, another cam example is called conjugate cam. there also the groove, the followers completely in contact with the shape of the cam. That's why whatever follower shape is there, geometry of the cam is there, the rollers will oscillate. Now, next one is called gravity cam. If the rise of the cam is achieved by the rise of the surface of the cam and return by the surface of the gravity or due to weight of the cam, that's why it is known as gravity cam. Now, coming to the category, so far we have studied types of cams. Now, types of followers. So, what is the types of followers? Again, shape, number one, and first category is the shape category. Second category is movement. Third category is the location of the line of movement. Now, according to the shape of the follower, if the shape of the follower is knife edge, then it is called knife edge followers. Then it is called knife edge follower. And it is a very quite simple construction. Okay. It is, and one more thing, the wear is the wear and tear. It uses for very limited operations, but great wear will be there. The wear is the point. This point is very knife edge. Knife edge will be there in contact. That's what is the surface, the point contact. That's why when the cam is in point contact with the surface of the cam, then it comes under the category of higher pace. Now, roller follower. In the case of roller follower, the shape of the cam, one end is the roller. Okay, roller follower. So, when the cylinder, it is a cylindrical surface, roller, free to rotate about a point joint, okay, about a pin joint. So, at low speeds, the follower has a pure rolling motion. But at high speeds, what will happen? Not only sliding motion occurs, and also jumping motion occurs at high speeds. Okay, at high speeds. In the case of knife edge follower also, the jump will be high. But here, the point is that sliding takes place. So, that's why this roller followers, the coefficient of friction is low compared to knife edge follower. So, therefore, and also sometimes, a roller follower, also what will happen? Jumps. What is the jamming? It stops transferring the motion. The displacement of the follower becomes jam. So, at that time, what will happen? That's why this type of cams, follower, this type of roller followers is not preferred for transferring the torque from camshaft to for camshaft to driven members. Next category based on the shape. Here the shape of the follower, you can see it is the flat faced follower. So this is looking like a mushroom. If you see the mushrooms, this type of shape is a mushroom. That's why these types of followers are called mushroom followers. So what is the advantage of, okay, but the shape is the flat face, but here it is a spherical faced follower. So a mushroom follower has the advantage. What is that advantage? It does not pose the problem of the jamming the cam. It doesn't. As in the case of roller follower occurs. So here it doesn't occur in the case of mushroom follower. That is jamming. Cam doesn't jam. Next, high surface stresses are okay. Here the point is that the stresses, high stresses and wear are quite high. But the contact between this mushroom follower face, flat face of the follower and the cam is the point contact. It is a point contact. That's why these all cam and followers comes under the category of higher pace. Okay, that is the first category. What is the first category? Based on the shape. 1, 2, 3. What are the knife edge follower, roller follower, mushroom followers. Under the mushroom again flat face and spherical faced follower. Now according to the movement, second category. The second category of the cam, there are two types. Number 1, reciprocating follower, and number 2, oscillating follower. Number 1, reciprocating followers means We have studied already here in the figure, in the case of chapter 7 figure. Okay. In this type, as the cam rotates, the follower reciprocates or translates in the guides. Let us see what are the types of cams are here. This is the cam. This is a reciprocating follower. As the cam moves, the follower always vertical translatory motion in the guides. That is called reciprocatory motion, reciprocating follower. Okay. Now, coming to here, oscillating followers. The follower is pivoted at a suitable point on the frame and oscillates as the cam makes the rotary motion. Here, the rotary motion is mentioned here. In the case of figure 7.1b, it is not a rotary motion. It is horizontal translatory motion. This figure is wrong. But the meaning is that the follower is pivoted at a suitable point on the frame and oscillates as the cam makes the rotary motion. When the cam makes the rotary motion, suppose if the cam makes, this is the cam, makes a rotary motion. For that, suppose I am considering here knife edge follower. When the cam rotates, the follower, it is a reciprocatory motion. But the cam is designed in such a way that, as in the case of conjugate cam, as in the case of conjugate cams, what will happen? It oscillates. It oscillates, oscillatory motion. That's why it is called oscillating followers. We are talking about oscillating follower. The follower is pivoted in such a suitable point on the frame and oscillates as the cam makes the rotary motion. Now, the third category, if you understand, very important. So, according to the location of the line of movement, there are two types of followers. What is there? Radial follower and offset followers. What is a radial follower? The follower is known as a radial follower if the line of movement of the follower passes through the center of rotation of the cam. I will explain more detail next. What is next? Offset follower. It is opposite. It doesn't. The line of movement of the follower surface is not. Okay, it's not. It is offset. That means offset means away from the center of the cam, rotation of the cam. Then the follower is known as offset follower. Now let me discuss more. Here, what is radial follower? Based on the line of movement. Next category is that offset follower. So this radial followers, what is the meaning of radial follower? Suppose it is the cam. The axis of the cam is, okay, the line of action, the radial axis. The rotational axis is normal to the surface. Normal to the cam's surface is the rotation, that axis. But the radial axis, now, this is the cam follower. I am considering this is a guide and is follower. This is also axis of the follower. The axis of the follower is coincidental or passing through the radial axis, radial motion. Okay, let us see. That is the meaning here. The follower is known as a radial follower if the line of movement of the follower passes through the center of rotation of the cam. Okay, very important. the line of movement of the follower. The line of movement of the follower means the line of movement of the follower passes through the center of the cam. This is the center of the cam. Then it is called, what is the center? This line passes the radial line. That's why it is a radial follower. Now, what is offset follower? The line of movement of the cam does not in touch with the center of the cam. Suppose this is the cam. This is the center line of center of the cam, but your follower is somewhere else here, in touch. Now when it is rotating, the follower also converts translatory motion. Under translatory motion, the rotary motion of the cam is converted into reciprocatory motion of the follower. But the point is that, okay, converts into reciprocatory motion of the follower. But the distance, the axis, the line of motion of the follower, this is the line. This is the center of the cam. The distance from line of motion of the follower to the center of the cam is called offset distance. That is E. Offset. It is offset. That is the meaning. But whereas in the case of radial cam, the motion, the line of the axis of the follower or the motion of the follower is always in touch with the center of the cam. Center of the cam is line of center of the cam. It is here only. Whatever motion may be, don't think the follower will go like that. The cam will rotate constantly at this fix, and the follower is also fixed, but it is guided at this line. It is remains same. So that is the difference between radial follower and offset followers. Okay, these are the another category of the followers. We'll discuss more about in types of followers. Suppose while solving the problems, what will happen? We have to draw a cam profile based on the data is given. Suppose what they will do, what data will be given here, the follower motion. If the follower is under the motion of uniform velocity, during raise and uniform acceleration or uniform retardation during return. So here, rise, return, and again it will rise. So this comes under the following follower type is called rise, return, rise category. So based on the velocities, the motion of the follower, there are various types of motions are there. The various types of motions based on the various types of motions. Various types of motions are uniform velocity, number 2, uniform acceleration and retardation. And third category is simple harmonic motion. And fourth category is cycloidal motion. These are the 4 types of motions the follower can move, can displace, can move Under again category, if the line of or the motion of the follower is in touch with the center of the line of the cam, then it comes a radial cam. If it is radial cam or offset cam. So what are the factors affects the cam profile? Or factor number 1, the type of the cam and the type of the follower. The type of the cam and the type of the follower. The type of the cam and the type of the cam and the type of the follower. Factors affect the profile of the cam or design of the cam. So there are various factors as I mentioned just now. Type of cam and type of follower. Type of follower. Next category. Type of cam and motion of the follower. Again, if the motion of the follower, again, motion of the follower during rise or return. There is no motion during dwell. That's why it don't mention here during rise, dwell and return. No. Dwell remains, there is no motion. Whether it may be simple harmonic, nothing affects. Dwell means, as I mentioned in before lecture, it is a zero displacement of the follower. Absence of the motion of the follower during the angle of rotation of the cam. It is known as dwell angle or dwell period of time. But the time is converted in the angle. Now these are the factors affects the design or profile of the cam. Yeah, fourth category is if the type of cam is, if type of follower is, here again types of followers are there, different types based on the shape, based on the movement and based on line of action. The line of action means again radial follower or another one is called offset follower. It's very important. So there are again types of cams. Again during types of, especially we study here the types of cams category is called types of cams. We'll follow radial type of cams, not conjugate cams. We don't follow. Let us see here during solving the problems. We'll follow what type of cams. The type of cams we'll follow here. This is the type of cams that is called arc cam. This type of followers will follow. That is called radial or disc cams. We'll draw cam profiles. We don't draw the cam profiles of wedge cams or spiral cams or conjugate cams, cycloid cylindrical cams, etc. We don't draw. We will draw the shape. Only radial or disc cams profiles are drawn in this, will be drawn in this module. Especially the 7.3a we will draw. And what type of follower we follow? The followers, we don't follow this grooved edge and all. We don't follow this type of closed pair followers. We follow knife edge followers and roller follower, and third category is flat faced follower. That is called mushroom followers. So under these categories, under these three type of followers, we follow only one type of cam, that is radial or disc cam profiles are going to be drawn in this module under the conditions of What are the conditions are? Under the conditions are, what is the angle during rise, what is the angle during dwell, and what is the angle during return, and whether the follower is a radial follower or offset follower, and the follower shape. Under all these conditions, we are going to draw the type of the cam. The profile of the cam is radial cam profiles only going to be drawn, going to be designed in this module. So we don't follow here, we're not considering the preloaded spring cams conditions, okay, but we follow according to the shape. And movement, reciprocating or oscillating, we don't follow, but line of action. These two types of followers, what are they? First and third. These two types will be followed, not second category. Okay, those are type of followers will be followed. And type of cams, in the case of types of cam, only one type, that is called radial. It comes under the category of shape, under the category according to the shape of the cams. Okay, with this, we'll stop today. Thank you. We'll continue. What is the base circles? Okay, definition of the cams, displacement diagrams, etc. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.